Hello guys, welcome back to the channel. We are doing Leetcode 2570, merge two-dimensional arrays by summing values, which also happens to be the problem of the day for today, which is 2nd of March. So let's see what the problem statement says. It says you're given two-dimensional arrays, nums1 and nums2, something like this. And what you have to do, let's first have a look at what the structure of those two arrays is. So each of the index is going to have two things, id of I and value of I, such that the number with id of I has a value equals to value of I. So in nums1, the number with the id 1 has value 2, the number with id 4 has a value 5, so on and so forth. The same argument goes for nums2 as well. Each array contains unique IDs sorted in ascending order. What we have to do is merge the two arrays into one array that is sorted in ascending order by id, respecting the following conditions. So what are those conditions? Only IDs that appear in at least one of the two arrays should be included in the answer, obviously. Each ID should be included only once. Okay, so I can very clearly see over here that 1 is present in both of them, and what I do with it in the answer arrays, probably I add 2 plus 4 becomes 6. Yeah, and then similarly I have 4 over here as well, 4 over here as well, so 5 plus 1 becomes 6. So what you can do is sum of the if there's this id, this particular number which is appearing in both of the nums, then what you have to do is include it only once in the answer array and then just add the respective values up. So the very first thing that it tells me, this particular question tells me, is that I have to make sure I have to keep this factor in mind, the uniqueness of the IDs, right? The uniqueness of the IDs. So what data structure can I use? What data structure can I use which does these two things actually? Which stores, if I have to store a unique ID, so that particular data structure should have the capability of storing unique elements. And then the other thing is that I have to, if for example, if it's present in the other array as well, so for example 4 is present in this one as well, do I have that data structure should also have the capability of doing this. So for example, I iterate through nums1, I say that 4 was present in nums1 and the score against that was 5. Now when I'm iterating through nums2, I should check whether or not 4 was present in the nums1 as well, and this lookup should be as efficient as it can. So if it was present, what I'll do is I'll just update this. I'll just add this 1 to this 5. It's going to become 6 and no longer 5. And similarly, I'm going to do the same logic for every other number as well. For example, if I was talking about 2 wasn't present in nums1, right? So I'm just going to assume, as they're saying, that if the ID does not exist in one of the two arrays, assume that its value is 0. So again, you know at this point what data structure am I talking about? I'm talking about a simple map, right? A simple map of int, comma int. And why am I saying that this is going to prove useful for us? Let's have a look. So let's say I have 2 against value of 1. I'm going to take a map, I'm going to take an ID over here, and I'm going to take a score over here, right? I'm just going to assign the score of 2 against 1, the score of 3 against 2, and the score of 5 against 4, right? This is the resulting thing that I get after I have applied all the operations on nums1. Then I iterate in the nums2 array. I very clearly see that there is a score of 4 against 1. So what I'm going to do is I'm going to see what was the previous score which was stored against the ID 1, and I'm going to increment it by 4. You see, so this is now the new value of it is going to become equals to 6. Now I get 3. 3 is not present over here, right? So I'm just going to go write 3 and assign it a value of 2. Similarly, I'm going to see if 4 was present inside the map already. In other words, did I find 4 in my nums1 array? Yes, I did. So what I'm going to do is I'm going to increment this by 1. The new value of this is going to become 6. Now, you can very clearly see I have the score of 2 against 1. Sorry, I have the score of 6 against 1, let me 6 against 1, 3 against 2, 3 against 2, 6 against 4, 6 against 4, and then 2 against 3, 2 against 3. But then the incorrect thing is that these IDs are not sorted right now. The good thing is map actually sorts the IDs automatically. So when you are working with a map, it automatically sorts the keys, right? And therefore I'll not be using an unordered map. I'll be using a map. Say a map by default is sorted. So what it's going to do is it's going to sort the IDs 1, 2, 3, 4. This is going to be the correct order. And when I iterate over these rows individually, and basically, so since I have to return a 2D vector. So when I iterate over the map, it's all automatically going to give me the answers in a sorted manner, right? So let's see how we can do this inside of our Leetcode. I'm going to do is I'm going to create a map. I have already done that. I'm going to create a 2D array of answer which I have to return from this function, and then I'm just going to do what I did over here. What did I do? I traversed over nums1 and I stored every score against its respective ID. So it can be as simple as that, as this. So for each number that I have in nums1, I'm going to assign that to the map. MP of actually, oh sorry, no, actually I have two things inside of my nums1, right? So this is actually going to be a row wherein row 0, wherein, let me actually write this down, wherein row 0 is the ID, and the score is row of 1. Is that correct? Right? And I just have to assign the score to that particular ID. So MP of ID is actually going to be the score. Now, so half of the thing is done. I have 2 against 1, I have 3 against 2, I have 5 against 4. Then I'll iterate over the other array, the nums2. I can just copy paste this, by the way. But the thing is, I don't have to assign the score. I actually have to add it to the previous. Right. So for example, there are going to be some IDs. There are going to be some scores which have already been assigned to this ID. For example, 2 already has a score of 5. Now, if I have 2 in this nums2 as well, and if it has a certain score against it, I'm not going to assign it, I'm actually going to add it. And this works in both cases as well. For example, if I have some ID, for example, I have 3 over here, 3 was not there in nums of 1. So when I say MP of 3 plus equals 2, it's actually going to assume that the by default score against the ID of 3 was 0. So it's going to add 2 to 0. Ultimately means the same thing. I can very well apply this plus over here as well. If the thing is this, let me tell you a very fundamental rule about maps. If you do something like this, MP of 10 plus equals 10, and let's say that 10 wasn't present in your map initially, it's going to assume that MP of 10 initially had a value of 0. You see, so that's how it sort of very perfectly fits our use case over here. In the end, what I have to do is so my map actually looks like this. I have to go over each row of the map and just put it inside of a 2D array. I'll do exactly that. I'll say something like this: for auto row inside my map, just go over every row and create a vector. So I'll create a vector something like this, current, and that current is going to have only two things: row dot first, which is the ID, which is the ID, and row dot second, which is actually the score, right? And I'll just push it back inside my answer array, right? Ans dot pushback, current, and then I ultimately return the answer. As simple as that, right? Let's see if it passes all the tests in auto row actually, because this is a 2D, and I can also write, by the way, vector of int over here if I have to be more accurate. Doesn't make a difference. right? Let's see if it passes all the test cases. It doesn't. Why does it not? um 1 4 2 6 4 10. Oh, sorry, I did nums of 1 over here. Nums should have been nums 2, right? Let's see if it passes all the test cases. It does. Let's submit it. Right, it gets accepted. Now if we talk about the time complexity and the space complexity, we can very clearly see that we are taking a map, right? If we talk about the space complexity first, and the in the worst case, I'm going to have 1 2 3 over here, the IDs 1 2 3 over here, and 4 5 6 over here. So I have all unique IDs. So in the worst case, inside of my map, I'm going to have n plus m number of elements, right? Wherein n is the number of elements in nums1 and m is the number of elements in nums2. So in the worst case, the space complexity is going to be O of n plus m, and the time complexity, you can very clearly see that I'm only traversing over each of these values just once inside this loop for nums1, once inside this loops for nums2. So that makes it O of n plus m, and then inside of the map, I just traverse all of the rows again. So in the worst case, I'm going to have, n plus m number of entries inside of my map. So this is again n plus m number of traverses, n plus m number of traversals as well over here. So the space complexity is also O of n plus m, and the time complexity is O of n plus m as well. So I hope this video was helpful for you. It was a very easy question, and if you want to see more like this, do let me know in the comments. Thank you. I'll see you next time.